Hello everyone, and welcome to our next module, Designing an Advanced Application. I'm Walter Myers, and I'm joined by...
This is Michael Withrow.
Michael Withrow. We're both Cloud Solution Architects with Microsoft, and we want to talk to you about sort of conceptually, how do you design an advanced application? Now, both of us have worked with customers for many years in consulting services, so we know the importance of really truly understanding what is it that a customer wants to build a given solution. What does it take to design that solution properly? And we know with Azure, it's a growing platform. There's lots of things going on in Azure, lots of different services and lots of different things that you need to consider when you're designing an application. And I like to sort of think of things as being scenario based. So when preparing for this exam, what I would ask you to think about is what might be the scenarios when you're going through the section on designing an advanced application. What are the different scenarios that might come up, and what do I need to think about as I'm working through the scenario to come up with a solution that will hopefully allow you to do well, on the test, and particularly this particular section. So let's get started. My module here will start with sort of the Azure design mindset. With the various experience that Michael and I have, we want to just help you sort of understand what is the mindset when you're designing around Azure. I mean, it's new, it's out in the cloud somewhere, and we've got all these different types of services and things we have to think about, hybrid and all those and what's on-prem versus what's out in the cloud. But I think it's just a matter of how it is that you think through these things. We'll talk about compute-intensive applications. Also, then we'll talk about long-running applications, web roles versus worker roles, those types of things. We'll talk about some of the different storage options that you have in brief. And then finally, we'll talk about various Azure services. But all of this is with respect to designing an advanced application. So let's talk a little bit first about the Azure design mindset. When you think about Azure, I think probably the first thing you think about, Michael, is scale. Mm-hmm. How do you scale an application? You have on-prem, you have certain limitations in terms of how big your data center is. But what we're offering is the ability to massively scale. You don't have to worry about that any longer. We'll worry about that for you.
Yeah, what its presence is going to be.
Exactly, and what you're going to do on-prem versus off-prem versus a cloud. Mm-hmm. How you can make those two work together and also, it's about services. So much of Azure is about using the various services and using those services properly. And it's about composition. How do you take all those various services and you compose them into an overall solution? And I think that's an important thing to think about as you're preparing for the test. How do I design applications? How do I bring these different parts and pieces together to make something that delivers for a customer? Also, consider all storage options. I mean, Michael, we have so many different storage options. Right. We have Azure storage. We have lots of NoSQL type thing, NoSQL options. We have SQL Server on IaaS. So how do you sort of look at all those different things and say, what is the right option for my given application that I want to deliver? Yep. Also, there's HANDR, and obviously for enterprise customers, us working with enterprise customers, we always get the HANDR questions. What are all my different options? How do I need to think about disaster recovery? What happens if an Azure data center goes down in some particular region? Well, how do I spin up and go to another data center?
What's my backup story?
What's my whole backup story as well? So we need to really thinking about those things when you're designing around Azure, because that's the expectation with Azure, is that you will be able to be responsive. You will be able to, if you're down, you can come back up and you can keep moving. Yep. Also, I think another thing that we need to think about is in the Azure mindset is, even with respect to HANDR, well, should you go active? Or should you be active versus passive across data centers? Or what in a particular application, maybe you want something that's more distributed. So if any particular node goes down at any time, you can spin right back up on the other one, and you can take advantage of the constructs that allow you to do that. Yep. So I think those are some important things around the Azure mindset. Yep. Also, worker roles versus web roles versus VMs. How do I use those? What's the best thing in any given solution that I'm developing? What is the best thing? What's the best route to go with that?
Yeah, these are the biggest things in my mind, right? If you look at Azure, right, you don't want to really get in a mindset of I'm only developing this application to be an IaaS-only application or a PaaS-only application, whatever it is. You want to understand the services holistically to understand, hey, look, it might be a blended application, right? I might be using infrastructure as a service SQL because Azure SQL doesn't line up to my requirements. requirement.
Exactly.
But then I'll be using Redis or a worker role, or maybe I'll be using websites with a worker role or Azure websites, or maybe I'll have to go to a web role, right? So all those nuances are really the things you want to understand.
Exactly. In terms of how do we compose a particular solution and all the different things that we can bring to bear to deliver that particular solution.
Yep.
So we'll get now into a little bit into compute-intensive applications. And what sort of is big compute? I know it's sort of a buzzword. Big compute, big data, all those types of things. But really, when you think about big compute, think about the different jobs that may come up or the different scenarios that may come up. For example, you have media transcoding. You're working with media services. You're working in video production, those types of things. Well, the big compute is a good candidate for that. Or if you're doing rendering of any type of video, those types of things. These are things that are long running. They can take not just hours, but sometimes they can take days or even months to do rendering. Well, how many people have that capacity in their own shop to do it entirely on their own? Well, with Azure, you can do this, you can scale this, and you can sort of be just like the big guys, right? Okay.
Would it run faster on 2 servers or 100?
Exactly, or whether 2 servers or 100, we can give you that. We can give you that capacity. Image analysis and processing, fluid dynamics. There are just a number of different things that you can do in Azure with respect to doing very highly compute-intensive, parallel-oriented type processing activities. So just to sort of look a little bit at big compute, so you'll understand this as you're preparing for the test and what you'll be faced with in the test. So big compute is, say, you take many individual tasks. And then you have all of these machines, and you assign those tasks to virtual machines. And like Michael was saying, it could be 2 machines, it could be 100, it could be 1,000 machines. It's as many, and typically what we would look at is in terms of cores. You may have 1,000 cores, 10,000 cores in certain Monte Carlo simulation, those types of things, and it could be dynamic. It could scale up or it could scale down. So you have that flexibility with Azure. So you can have any number of VMs assigned to those tasks. They can be independent, they can be coupled, and that these independent machines are talking to one another, sharing information across them, and as well. And then you have some type of output that you're getting from this. So this could be some video that you're producing, or it's ultimately some calculations from fluid dynamics, or some type of simulation that you're running. So or engineering type applications. This is where you really start to think about big compute and what Azure can bring to the table as far as helping you with those types of workloads. So why use Azure? Well, the thing is, Azure provides you a managed platform for doing this. It's a set of services that we give you. And also, those are services that we said before that will allow you to scale. It's elastic. You can scale up and down. Also, and the great thing is that you only pay for what you use. So for example, if a customer's had a huge data center on-prem, they're paying for that data center. Well, they're paying for that regardless of what they use. They're paying for it. They're paying for the whole data center.
Yeah, it's an upfront cost.
Exactly. Whereas what Microsoft has done is we've made those investments.
We've already
and so it's already out there ready for you to use. So it's just a matter of you paying for what particular aspects of or services that you use on the Azure platform. And of course, you can use whatever you want on-prem as well. It's a matter of how do you compose what you're doing on-prem with how Azure could complement what you're doing on premises.
And a lot of scenarios, kind of go into that too. A lot of scenarios, when you're talking about an advanced application, it might include some hybrid as well.
Right, and you worked a lot in hybrid, Michael.
Yep, exactly.
So what are some of the new possibilities? So just as we were just saying, small organizations with no on-premises servers, Azure is an ideal environment for you to run your simulations, your big compute type things because you don't have it on-prem. We'll provide it for you. It can be cloud-only scale. We can run up to hundreds of thousands of VMs. Now, I think before they run 100,000 VMs, they need to call us, right, Michael?
Yeah, it might have to do a compute ticket.
We might have to do a compute ticket to do that if you want 100,000 VMs. But we're happy to oblige you in one of our data centers, and you can do things that previously were simply not possible for you to do. So if you look at sort of the big compute evolution, we've had the high performance computing pack on premises for years. So it's on premises Windows clusters. We would help you to do the scaling and the scheduling and the management of it. But then as time went on, we sort of did a hybrid thing where we could actually start to extend those clusters that you're working on-prem into the cloud to handle peak demand. So that's more of a type burst mode into the cloud. where you could leverage the cloud for that. Also, we would allow you to do automated deployment of Azure virtual machines. But then as we've gone on, HPC PAC was then updated to say work with IaaS. So what we could do is deploy those clusters all in the cloud. You could move your existing applications up into the cloud and run all of those things there. And then we would give you all the configuration tools for actually setting it up. But the next step of this is the PaaS play. Right? In the PaaS play with the Azure Batch PaaS, with that model, we have a native cloud scheduler. And we can do small to very large deployments, but the thing is you don't have to do all the management work that you had to do before. We do a lot of that management work for you with Azure Batch.
Yeah, which is the native, conversation between IaaS versus PaaS, right?
Exactly. So we've sort of lowered the bar a little bit in terms of what the customers have to do. They don't have to worry about all the underlying patching of the virtual machines. We do all that underlying work, and they can really just more look to it as a service that they can leverage in the cloud.
Yep.
So previously, if it's, say, in an on-premises type situation and hybrid big compute, you'd have the HPC PAC. So you would say have your on-premises head node and compute. Now this is going to be important, I think, for you on the test is to know what are the different models for how you might use HPC leading up to its evolution into Azure. You may also have what we talked about before, on-premises head node, but then you would have your compute might be on-premises, but then you would extend that into the cloud. Next, you might just have your head node sitting on premises. So this is a hybrid scenario we were talking about before, but you'd have all the compute and all of your virtual machines that are doing all your low-level computations that are in the cloud. But in Azure, we've got the HPC clusters entirely in Azure where you can have access to those thousands of cores. We do have remote direct memory access support with the A8 and the A9 virtual machines. It's a very low latency network with those A8, A9 machines. Also, if you have message passing interface applications, in other words, the ability for applications that are running in massively parallel to exchange information across those machines, we have that with our HPC capabilities, and also the ability, obviously, to burst to the cloud on demand. Whatever you're doing on-prem, we can allow you to burst into the cloud.
Yep.
So here we just have a picture on-premises, head node, and cloud cluster. So this is sort of a hybrid type scenario where we're running some on-prem, some of it in the cloud, pretty much your head node, but all pretty much of your processing or your computational work is going on in Azure. So let's talk a little bit about Azure Batch. I think the way to think about Azure Batch is basically job scheduling as a service. You have these applications, these executables that you're currently running on-prem, and you want to be able to scale those up. You want to be able to basically in a batch type mode to be able to scale these up, run these in the cloud. And what we do with Azure Batch is we sort of give you that environment. We wrap that around that where we'll actually do the virtual machine management for you and the job scheduling, all of that stuff. We give you that foundational batch processing service. And what you can see is we can place that up into IaaS virtual machines. And we'll basically and we'll run all of that for you, all the scheduling and everything in those virtual machines. But we don't just stop there. With Azure Batch, we also have the ability to do the application lifecycle management. So we'll also do we'll move the data up into the cloud for you. We'll manage users and authorizations, and we pretty much can take over the whole process. So it's not just a matter of just managing the VMs and scheduling things out, but we actually can cloud enable your on-premises applications and move them up to the cloud and make you productive with the Azure Batch.
Yeah, so it's not just a raw, 1,000 VMs of capacity just sitting there for you to leverage. There's actually an intelligent service on top of that to really compile your data for you, run your jobs.
Exactly, to take you and actually move those workloads into the cloud and to help you actually do that with the services that we provide, such as with the Azure Batch service. And that's why it's such a key component of the whole high-performance computing environment that we have in Azure. Is Azure Batch sort of gives you that next level of management, if you will, for HPC computing. So we're going to move over to long-running applications where we'll talk about worker roles and scale and sort of going stateless. Now this is one of me and Michael. We have a shared like for this particular slide deck, because I think this really crystallizes, and I think if you really truly understand this slide, you're halfway there in terms of truly understanding Azure and what is the value proposition or what's the value equation to Azure. Because if you think of, say, for example, let's just look at it in terms of whose responsibility. If you're on premises, everything is your responsibility. You have taken all the risk. You're running everything on premises. You have to scale everything. You have to manage everything. Everything is pretty much on your feet, right? But what we can help you to do is we can help take some of that in terms of reducing your costs, give you more flexibility as you move into Azure with access and control that we give you, that we provide at varying levels within Azure. So if you look at IaaS, you'll see all the networking, storage, servers, all the virtualization stuff. You don't have to worry. The customer doesn't have to worry about that.
Right.
So Microsoft covers all that. But then when it comes to OS, middleware, the runtime, data in the applications, then you would deploy those to the machine. That means you're actually managing that machine. You're not managing the underlying virtualization type stuff, but you're just basically managing the applications. So that's very important to know as you're building applications, or you see a scenario where a customer says, I don't want to manage servers. Well, if they don't want to manage servers, then IaaS probably is not the best solution for them. But if they want to sort of take this to the next level where the runtime, the OS, all of that stuff is taken care of, all the patching is taken care of, then with PaaS, it's just a matter of you worrying about the applications and the data. You deploy your data, you deploy the application to our particular model with respect to platform as a service. And obviously, it's a little bit harder because you have to write to the particular PaaS model. It's not like you can sort of lift and shift. You have to write to the model. But what it gives you is cost benefits and not having to worry about servers. You're managing services. You're not managing servers. And that's what I've heard some of my enterprise customers say. They want to manage services, not servers.
Right. This is the good slide for the return on investment story.
Exactly.
So as I evolve up the stack, I'm going to get a deeper and richer return on my investment as I evolve up.
Exactly. And then, of course, we have the software as a service story, and that would be something such as Office 365. Where Office 365, it really is just a matter of the customer configuring the software the way they would like it. They don't have to worry about anything else other than just a configuration of an application that's already running that has a purpose, such as what am I thinking? SharePoint, such as SharePoint, Outlook. The ability to have Outlook, Word, Excel, all those things in the cloud.
Yep, as a SaaS application.
As a SaaS application. So, this is another great slide to sort of give you that distinction in virtual machines between IaaS and versus PaaS. What you have to remember with respect to designing applications around PaaS is that PaaS is non-persistent storage. Every time that virtual machine reboots, it's like starting from scratch. Anything that you need to install on it, you need to install it all over again. So those are the things to think about when using PaaS. Comes out of the stock VHDs, and this is really where we're talking about stateless, scale-out applications.
Yep.
This is where you're running your web applications, web applications, those types of things.
Yep.
Or in this case of a worker role, specifically we're talking about a worker role here, it's doing all of that sort of back-end processing. So you might have a web role that's doing the front end, the website, but then the back-end processing in the worker role would be that stateless scale out, and obviously it is persisting its data to a database because there's no storage per se other than storage that is non-persistent in terms of the worker role. Whereas a virtual machine IaaS, of course, it's persistent storage. Every time you reboot, it's just like you're on-prem. You can always add additional storage. You can add additional data disks to that. We have up to 32 now, all depending on the size of the virtual machine that you selected. And you can deploy virtual machines that you've built on-prem and simply upload it, or you can use our stock VHDs. Internal endpoints for virtual machines are open by default, but that doesn't mean that someone automatically has access from the outside, because we only open certain ports to those machines, such as RDP and for PowerShell, to access those internal endpoints, which of course you can, through the ACLs, you can actually change that access control to that to customize it the way you'd like it. So really the primary use of virtual machines is applications that require persistent storage so that you can run those in Windows Azure. And this is where we see more of the lift and shift type scenarios would be to IaaS.
Yep, and so kind of going on that as well, just to kind of further that point is fundamentally under the covers, it's important to understand, there's a lot of shared capabilities. The compute layer underneath for IaaS and PaaS and Azure is the same, right? It sits on the same hardware underneath. It leverages the same clusters, the same fault domains, the same update domains that we talked about before. It's just the deployment model and the responsibility of the customer is what's going to differentiate between IaaS and PaaS.
Yep. Exactly. So now we'll move on to storage options. Now I think this is very important. This is key. There are many different storage options, Michael. We know there's a plethora of storage options, and we have customers all the time asking us, well, how do I use any given storage option? When do I use Azure Storage? When do I use table versus blob storage? When should I use queues? When should I use SQL database? Or
should I use caching?
Yeah, when should I use caching? I mean, those are a lot of things. And when you're thinking about the test, you will probably be challenged with those things in terms of thinking about, you may be given some particular scenario, some particular problem you're trying to solve, and your ability to pass the test will be to the degree that you can understand truly what the requirements are and what is the right storage option to choose for any given scenario. Given on any given scenario that you may be presented with. So let's just take a look for a few minutes at the different data storage options. And I really like this slide. I found this somewhere, and this is actually up on, you can find this, this slide up on MSDN. But if we look at the different storage options, let's just sort of start with relational databases. You have Windows Azure SQL database, that's a relational database, or SQL Server, or we have the Oracle VMs. So those are things that are relational. And what's great about the relational databases, obviously, is that they're very queryable, right? But the only thing about that is that even though they may be queryable, they may not have the capability to sort of scale like you would like. In other words, you can't exactly sort of scale these across multiple data centers throughout the world. The type of resiliency you might want if a data center goes down to, say, be able to spin up in another one. And obviously you can do that with SQL Server, but that's not something that may be practical for a lot of different types of applications that are massively scalable and need to be up and running 24/7 across multiple geographical regions.
Getting into a sharding conversation.
Exactly, getting into sharding conversations and things like that. So, so if you look at some of the other NoSQL type options, the NoSQL type options give you sort of that massively parallel scaling type capabilities. So if you look at, say, for example, Windows Azure Blob Storage, in this particular case, you're just basically saying this key value pair is just something that says, I have something in particular storage in this particular container, and I'm just simply referencing it. Whereas in Windows Azure Table Storage, you can't truly, you can query on a partition key, but it's very limited in terms of your querying. But the idea here is that it's massively scalable. You don't have any number of indexes in terms of that give you that really rich, robust queryability that you would get on SQL Server. But this would serve a different purpose in that case. Also, like Michael was talking about earlier about Windows Azure Cache. Key value type situation where you want to be able to gain access to stuff very, very, very fast, particularly probably more for your web application type scenarios. You want to be able to grab or be able to grab information very quickly. You would use a cache type scenario, but obviously that's not persistent. Or you look at the column family. So say, for example, I'm sure some of you are familiar with Cassandra. Now, Cassandra has become very popular because Cassandra is a column family. So basically, for example, if you say had a person, if you wanted to query on this type of NoSQL database, you had first name, last name, middle name, and you only wanted to query on those, well, that would be a different set to query on than, say, querying what the person's address is. So in other words, if you want to just query on these particular columns without having to worry about these given columns, so they're sort of segregated, you can query and you can get much better scale in terms of your capability in terms of speed as far as querying on these different columnar values. And so Cassandra is something where you might want to look where you say need really massive scale across multiple geographic data centers that are being replicated and those types of situations. That's why it's become very popular as it has been. Now, with respect to document type situations where and we do have document DB now, where we're in the space, but a lot of customers are looking at MongoDB because it's more document oriented. You want to be able to query stuff where this document based. So we're talking about XML or JSON based type documents where it's pretty free form, but you want to be able to query that fairly quickly, and you want to be able to distribute that across various data centers. MongoDB is possibly a good option for that type of scenario as well.
I've seen a lot of adoption in my customers around MongoDB.
Okay, great. Yeah, I've heard a lot of customers have been pretty excited about that, but now they're also looking at Microsoft Document DB as well as a player in that space. But certainly, when I look at people who really customers that want sort of that massive scale and replication type capabilities, they're definitely a lot of them are looking at Cassandra and looking at MongoDB with respect to different documents.
Yep.
So this slide here, I think, truly PaaS versus IaaS, I think it represents a very simple way to sort of look at this, and as well to as you're trying to work through your scenario, or if you're working with customers or whatever, basically in platform as a service, just think about SQL database, table storage, which is more, we'll sort of put that in the NoSQL group, or blob storage would be more for your unstructured file type stuff. Whereas table storage is more for your tabular type data, NoSQL type data. That's more a managed service, platform as a service. Whereas if you move over to infrastructure as a service, you're looking at things such as SQL Server, MySQL, Postgres, Raven, or Mongo. MongoDB would say, for example, be running on Linux, right? Where SQL Server you're running on a Windows server. And one thing about, say, for example, Windows Server and infrastructure as a service, if you do get any questions around, high availability and DR, well, we do have the high availability with SQL Server around always on. So always on was possibly something you will see on the test. And I would say, for example, if you had an HA type scenario, you would have a synchronous replica that's running in that same data center, so that in the event your primary goes down, you've got your highly available backup actually running in that same data center. But then what you also may have in the scenario is they may say, well, what's my DR scenario? What happens if a data center, Microsoft Azure data center goes down? Well, in that particular case, I might have an asynchronous replica that's running in some other data center. So say, for example, if I'm in the West and I'm in the East, West, say, may be my primary, and I actually have my asynchronous replica running in the East, but I may have an asynchronous replica running in the northern data center in the U.S. as well. I can pretty much run it anywhere I want. So you do have that ability with SQL Server to replicate that data across. Now, with respect to SQL database, you also have great options in terms of replication. We do have geo-replication with SQL database. We have various levels of that in terms of the speed with which we'll make sure that data gets replicated from one data center to another. So, but the thing is, in terms of making a decision of a SQL database versus SQL Server, obviously SQL database has some limitations. Currently, it's 500 gigabyte limit.
Right.
And to my understanding, Michael, the reason we have that limit is because we're keeping those 3 copies in a data center, and we're also copying it to other data centers. So we're trying to make sure we can meet the SLAs, and that's how come when some customers ask, well, why can't I have a 10 terabyte SQL database? And we're like, well, can you imagine what it would be like to replicate that thing? We have to do that.
I mean, I see those as that's really the key data points of this slide. Is if you look at the platform as a service capabilities versus the IaaS, the important data point here is really these are managed services with already HA and DR capabilities. SLA is already defined. It's important from a data set perspective to understand what those SLAs are, what those tiers of service are for those managed services. But on the IaaS side, I have to build in all that HA, DR in that environment.
Yes. Yep. Okay. Yeah, so in platform as a service, we're doing a lot of that work for you. In infrastructure as a service, you have to do that work, but there's certain workloads that obviously in tune with SQL Server. If you have a 10 terabyte database, obviously that's not going to work for SQL or SQL database, unless maybe you want to do some sharding, want to do a little work there. That may work for you. But I don't think you're going to see anything in the test as far as sharding and those types of things. I think they're going to probably keep it pretty much to, what are the performance characteristics of SQL database? How would you scale it? How would you in other words, what is the scale in SQL database versus how you would scale an IaaS application?
Exactly.
Right. Okay. So of course, it'll all come based on what the scenario is that you may be presented with. So with respect to Service Bus, we're really talking about secure messaging and relay capabilities and building those types of hybrid applications where you might have you're sending information from on-prem or somewhere entirely from the outside, you're accepting data. And what I've really seen in terms of Service Bus is where you have applications that are really of massive scale, Michael. You have situations where you just can't have enough receivers sitting there ready to write data, because you're writing data and that data has to be persisted. So obviously if you're receiving data and it has to be persisted, then you have to wait for that persistence. But what the Service Bus gives you is that opportunity to really quickly fire off something, forget it, and know that over time, that as your processing is taking place, it will eventually get to your data that comes into the Service Bus.
Just basically dump everything directly into the queue inside a Service Bus, or whether you want to have a relay service, whatever in there, or if you want to actually segregate that out and then you basically dump it into a topic as well to basically segregate that out to multiple receivers.
Exactly.
You have all those capabilities, so when you're looking at your applications, you really want to figure out exactly what feature set inside a Service Bus I need to leverage for my application.
Yeah, and we really do get the example. We do get the ability to loosely couple solutions. So look at Service Bus as also that way as you're composing applications. Instead of everything having to sort of go into one place and sit in one place and everything needs to take place in some one given place, then what you can use with the Service Bus, it really does allow you to increase your throughput, all depending on what type of service.
You can just offload this one call over here and queue that up, and then let that go.
And let that go while you're busy doing some long running processing, and it's waiting to process that. So we'll just sort of take a look at a Service Bus queue. So when you're sending data out to a queue here, you can have any number of people who are, or I say senders that are thank you, Michael, senders that are sending data into the queue, and then you can have any number of receivers. And in this particular case, so you've got a number of people, say for example, you're taking orders, and it's Christmas, okay, and you can't process all the orders. So this may be a scenario. It's Christmas. You're in a situation where you're really scaling up your capacity, right? And your processing can't take care of it all. Well, let's load some of that stuff up in the queue and let the queue sit there and make sure that it guarantees that message will get to your receivers. And so your receivers are, say, for example, all of your back-end worker roles, right, that are sitting there waiting for information to receive and actually process that information for you.
Yeah, I'm sure like healthcare.gov as an example could have really leveraged some.
I'm sure they could have used better leverage of queues. So in other words, you've got sequential message logs and message logs, and with competing consumers, and these messages will be consumed by this single consumer here. But we also may have a case where you have a lot of senders, but you may have something like a topic, okay? And a topic is pretty much a queue, but it's a little bit different in that with a topic, you have a publisher-subscriber model.
Exactly.
Where you may, not everyone who is on the receiver side, there may be certain messages that they want to receive and other messages they're not interested in, and that's why it's called a topic. They'll subscribe to the topic that they're interested in. So you may see a scenario in the exam where they're saying, hey, well, there's certain messages that are coming in, but there may be certain departments that want to get this, or certain applications want to get this particular information based on the type of order it is, or something.
Yeah, multi-tenant message type of thing.
Exactly. So this is a case where you may want to take advantage of topics where you have different receivers that want to receive different information. Okay, and let's keep going. Now, the SQL Database Service, now the reason I have this slide is we've already talked about this is database as a service, and it's fully managed by Microsoft. There's pretty much no administration on your part. But really, when you think about it, think about SQL Database as does have elastic scale and performance, and we've considerably improved it with the latest version and the latest announcement by Scott
understanding the SKUs, exactly. Yep. You know, the auditing capabilities that exist.
The auditing capabilities and auditing logging capabilities that exist today, and as well, pretty much we're on parity with SQL Server 2014 with the newer version. You're not going to be tested. I don't think you're going to be tested on that in particular here. But really, what you want to think about is about scale out. About the dashboard views, the metrics that you can see in the portal, particularly in the new portal. Also, business continuity. When we talk about business continuity, we talked a little bit earlier about the fact that what you can do with this is through the geo-replication, the ability to replicate across multiple data centers and to be able to do that in a prescribed way, and for you to have different levels of options in terms of how fast you want that to happen based on your given requirements, you really get that great business continuity story, and you don't have to worry pretty much about it. You just pretty much set it and forget it, and you let us worry about how we get that data replicated.
Microsoft the MDB file, and then Microsoft will manage the rest of that service for you, give you the SLA and the resiliency and the performance that you're looking for.
Exactly. So we've got that. So the DR pretty much is just a matter of checking a box if you want to have that DR capability with SQL Database Service, and it's pretty much your familiar tools. You can use SQL Management Studio to access that. You can do it's programmatic in that it's T-SQL, and with respect to self-managed, you don't have to worry about the management aspects of it. So it's great for you. Now, how is SQL Database different from VMs? I think this slide is very instructive in terms of sort of when you're looking at a given scenario in terms of saying, okay, what's SQL Server in a VM, Azure SQL Database? Well, how do I sort of decide on these? So if you look at SQL Server, if you have existing SQL Server, existing applications that require the full box product functionality, even though pretty much we're on parity with it, it's not full parity yet. So you may have some databases that may not have been candidates previous that would be candidates now to move into Azure SQL Database. But for the most part now, and I think what you'll need to know for the exam is existing applications that require that full box product functionality. You're going to want SQL Server in a VM.
So for this next data point too, for Azure SQL, so why is Azure SQL best for applications that require elastic scale, and how do I do that inside of Azure SQL, right? So is that something I can do in Azure SQL, right? Going through and then, hey, look, I'm on a standard SKU and I want to roll
that up to the next level SKU.
So how do I do that dynamically, or can I do that dynamically is an important data point to get your head wrapped around.
Exactly, great point, Michael. Also, in terms of resources, the customer, say, has an ecosystem of IT resources that they support and maintain. SQL Server and a VM, if you have those two people. But let's say we have a small shop here, and the small shop doesn't have much in the way of a data center. Maybe they just have a couple servers there, nothing in a rack or anything. Or it's a customer that just doesn't want any additional IT. They're customers that say, for example, their core business, let's say you're a financial services company or you're a media company. Your core business is not servers. These are just things that these are necessary things you need to run your business.
Consume.
Right, you just want to consume. So in that case, you may want to look at, say, well, if I move this over to Azure SQL Database, I just don't have to worry. I can focus on my core business. I don't have to worry about managing servers, right? Also, with respect to TCO, when in these scenarios, say you have a scenario where the CIO is expressing concerns about TCO and total cost of ownership, and they may want to move away from a CapEx model where they're making capital expenditures, building out data centers, buying servers, and all those things, and they want to avoid CapEx and they want to move more to an OpEx model. Then you can explain to them what the TCO benefits of this would be in terms of the expense and the overall savings over a period of time. So again, with respect to features, full SQL Server functionality you get in SQL Server in a VM, but you get programmatic DBA database type features in Azure SQL Database, and as we said, pretty much you're on par right now with SQL Server. So, and the story's much better, and as Michael was saying, even the ability to scale up your SKUs and get that elastic scale as you need it is a great new thing now from Azure.
But understanding the scale limits, which would dictate why I need to go from PaaS to infrastructure or vice versa, would be important as well.
Exactly, and that will be important when you get a scenario to know what that scale limit might be when you'll know that you need to move forward with SQL
key data
Server.
point is, hey, I have a 2 terabyte database. I guess that's going to, I'm off of Azure SQL. Now we got to look at infrastructure. Right?
Exactly.
So now I got to start building it. I got to think about my HADR strategy, my backup strategy for those VMs.
Precisely.
Capability.
So now we'll just move on to Azure Services. And John Platt, distinguished scientist at Microsoft Research, said, delivering on one of the old dreams of Microsoft co-founder Bill Gates, computers that can see, hear, and understand. Now, what is machine learning? It's sort of a buzzword. A lot of people say, oh, machine learning, it sounds really good and everything, but what really is machine learning? Machine learning is really, it's making computing systems that become smarter as they experience more, as they gain more experience. So that experience would be the past data that it's actually worked on, plus what are the humans that are actually interacting with it, that are doing work and actually learn more as it goes along.
Yeah, I mean, machine learning is really just experimentation, right? So it's a lot of figuring stuff out and break.
Exactly.
And then you get a breakthrough, refine it, keep growing and growing. And instead of doing that on premises in your environment, right, you leverage Azure for that compute resources to kick those experiments off dynamically.
Exactly.
And that's really the value prop there.
And yes, and you are learning as you go. So let's sort of take a scenario of how a business user might use this. So say you've got some data in the cloud that you've cranked out with, say, HD Insight, you've got SQL Server or SQL DB, blob and table data. It really doesn't matter the type of data. Or you may have some local data. Well, let's say you got that local data. You can push that up to Azure Storage. So you'll see here in the storage space here on the slide, I've got data from the local, and I'm moving it up in storage in some storage space, table storage, blob storage, or whatever. But then I can leverage the Machine Learning Studio, which is a tool in the portal that allows you to take that data. It's an integrated development environment that allows you to take that data and then to actually conduct and create experiments. Now, as you're creating those experiments, there will be some learning for you and some learning for the machine in terms of looking at that data, in terms of guiding it, in terms of trying to see what are type of predictive type analytics. So what are actionable things you can actually get out of the data? Actually do some type of trending analyses and those types of things. And then what you can do is actually expose the machine learning through an API.
Right through a web API.
Right through a web API. Now, if you don't know how to write your own web API, that's the beauty of Azure. We actually have a marketplace that will give you a number of different tools that you can use that will allow you to sort of monetize that API, and it'll generate those APIs for you so that you can expose those to different clients, whether it be devices or applications out there, dashboards, whatever, and deliver some business value out of it.
Yeah, so kind of looking at it from the exam perspective, it's probably important to understand what machine learning is, what an experiment is, how you kind of do that. Are there example topology experiments you can pull? How do you compile those, and then how do you expose those through the web API?
Exactly.
Right. So exactly, what does that experience look like right through the portal, through the ML Studio? That'd probably be a pretty important thing to know.
Exactly. And this slide, we just want to show you just some different machine learning scenarios. So say, for example, you may have a scenario, and that scenario may be something along the lines of sensor data analysis, weather forecasting, fraud detection. These are all the different healthcare outcomes. These are all of the different types of things that you can program in your experiments to look at the different data look at the data you have and try to see what those trends or those patterns are, or search engine optimization. There are a number of different things you can do in your experiments to actually help you to gain actionable type data or see different types of trending by taking advantage of machine learning. Now we'll talk now about media services. So media services are something that really allow you to say, if you're dealing with things like videos, you have encoding, you have packaging, distribution of those things. Well, before you had to have all of those things for doing pretty hardcore stuff, you had to have it all on-prem. Well, now you don't have to worry about that, Michael.
You just basically leverage our cloud power,
Exactly, you leverage the cloud. So if you have, say, live and on-demand streaming, you can literally reach, one little guy can literally reach millions of people, right, through these device endpoints, whether it be an iPad or Windows Phone or whatever, be able to access that, and you can do that all in Azure.
Right, just a matter of uploading your video to the cloud and then basically dictating how you distribute that from there, right? What are your players going to be, what devices you're targeting, what browsers you're going to target, all those kind of things like that. And then the architecture of that is a pretty important data point.
So also, if you have web videos for digital marketing platforms, so say, for example, you are producing internal training type applications, well, you can use media services for that, and then you can have that sitting out in the cloud that can be consumed internally, or it can be web videos for external uses. Also, the great thing is enterprise video management. So say you're a media company, and so you want to be able to distribute and manage, corporate communications, all those types of things. You can do that within your company, or even if you have, say, for example, a number of big media companies use media services to do the encoding and production and distribution of their their videos. So it's not something. It's something that's that we think is a service that can scale very well, whether it be for someone small or even at the enterprise level.
It ran the Olympics.
Yes, in fact, ran the Olympics, the Sochi Olympics. So just some examples of media services applications of subscription video service. You may have live event streaming, live to video on demand video services you can do with media services, and of course enterprise video management we just talked about.
Yeah, so a couple other data points in there too. It's important to understand, about how do I encrypt it? Well, I'm doing AES or DRM, the PlayReady solutions. Those are important things to understand too. What kind of capabilities exist there, right?
Exactly.
So we kind of talked about, hey, look, am I going to do video on demand, or am I going to do some live streaming? What type of players am I going to distribute to? What kind of browsers? And then kind of say, okay, how do I encrypt that, right? What do I get if I use media services with AES, or if I use it with DRM as an example? So there's price point differences. There's functionality differences as far as the keys handled, how the encryption's handled on distribution. Those are important things to understand.
Yeah, great. Okay, and finally, search. A lot of people probably don't know much about search with respect to Azure, but search is something users. It's sort of a natural, low-friction way to interact with applications that manage lots of data. And so, web search engines, Bing, Google, whatever, have really set the bar high. But what if you want to have search for Azure? If you want to have search for Azure, well, we actually have that as a part of the platform now.
Service, yep.
And the thing with setting up search engines, very few people can do it like a Bing or Google. So what we do is we give you that enterprise level search with Azure. So with respect to ranking, doing search engine optimization, those types of things, we'll provide those level of capabilities in the search capability of Azure Search.
Yep.
And sort of to give you an overview, so it's fully managed. It's a service. So you can set up a sophisticated search experience, whether it be through your web, your mobile applications, and you don't have to worry about all the complexities underlying of the full text search, because we'll help you to manage all of that infrastructure. So if you're an enterprise cloud developer, a cloud architect or whatever, and you need a fully managed search solution, then you can get that from Azure Search. You can surface your data, okay, and it's sophisticated searching, just like you would expect from Bing or Google. We reduce the complexity for you, and we give you faster time to market around your search with respect to your Azure applications. Now, the release timing around this, we came out with a public preview on August 21st, but we're expecting H2 of FY15. So pretty much that's sort of a Microsoft thing, but H2 FY15 pretty much means that'll be the first half of 2015 when you see Azure Search will come out of preview and go into BGA, and we'll have general availability. So that wraps it up for our session today, designing advanced applications. What we really hope that you'll take from this presentation is that you'll get a good idea in terms of how you need to think about doing this exam, and I mean, in terms of thinking about, I said how you do the exam, but in terms of thinking about how you need to approach this exam and what it's going to take for you to be successful in terms of designing advanced applications, and not only for taking the exam, but in terms of meeting with customers or whether it be in your own organization, how do you effectively deliver?
Leverage the Azure. Surface. Yep.
Leverage the Azure platform to build solutions. So thank you very much. And we'll see you in the next module.
Thank you.
Thank you.